You're hanging with Hussick, and this one's all about the volume of figures. Okay, the volume of any figure is the three-dimensional space inside the object. So, for example, if we look at this rectangular prism down here on the left-hand side of the page, what we see is how we end up getting the third dimension of volume. So we've looked at surface area, and if it's surface area, we'll have our answers in two dimensions. So it'll be something like meters squared or centimeters squared. The unit will be squared, and that's because we multiplied two things together to get that surface area. So, for example, if we took the area of just this face that's facing us, the front of this figure, that would be the area. So on this label figure, I've labeled it AB. The area of the base is what we were going to call that, because the volume formula for any figure is essentially the area of the base times the height. Okay? And so if we take that area of the base, which has 1, 2 figures, and then we multiply it by a third dimension, all of a sudden we're going to get that answer in something cubed. So it's going to be meters cubed, or maybe centimeters cubed, or what have you. Okay, so basically volume is the area of the base times height for any three-dimensional figure. And then what that's going to give us is it's going to give us all of the space inside the figure. Okay, so it's going to render a three-dimensional result. Okay, so let's practice this on the first example you see here. It's a rectangular prism, and we are going to apply the general volume formula that the volume is equal to the area of the base times the height. Okay, so we're going to basically assign the bottom the base. We could assign actually any one of these faces as the base, but whatever we choose as the base, the perpendicular dimension is going to become the height. So in other words, if we choose our base as I am here, as the 6.5 times 4.2 side, right, the squiggly blue line side, then the height is this, the 10 centimeter side. So we're going to take 6.5 times 4.2 times 10, okay? And then if you do that math, you're going to get, it's 273, what are the units? Cubic centimeters. What does this mean practically? It means that all of the volume, all of the three-dimensional space inside this object, if we were to fill it up with water, let's say, or fill it up with sand or anything like this, any sort of thing that's going to occupy that space, the volume of that stuff would be 273 cubic centimeters, which is the same as a milliliter, actually, 273 milliliters. Here's another example, okay, and there's, of course, no prompt in the question, but the prompt would be find the volume of this figure, okay? And so we know that the volume is equal to the area of the base times height. So let's choose one to be the base. Why don't we choose the bottom to be the base this time, just to show you it works either way. So we could make now, I'm going to just outline what we're choosing as the base. Okay, we could choose the bottom. So that is 10 centimeters, since area of a rectangle is length times width. Okay, a length of 10 centimeters. What's the width? Well, we see the 5 centimeter labeled here, and we see the little congruency lines here, meaning every side on the end is 5 centimeters, meaning it's a 5 centimeter sided square. Anyhow, that means that this value is also 5, and so it means our base is a 10 by 5 rectangle. And then we're going to multiply that by the height, which the height then becomes this measure, which is 5. All right? So then we're going to have 10 times 5 times 5. The order doesn't matter. It's all multiplying, and you're going to end up with 250 cubic centimeters. Okay, that's the volume of that figure. Okay, example 3, determine the volume of this figure. And this time we have a triangular prism. Okay, same general formula. We're going to look for the area of the base times height. Even though it's a triangular prism, rather than a rectangular prism really doesn't matter. Let's just assign, though, in this case, that the base must be the triangle, okay? So let's make the base the triangle on any triangular prisms. Okay, it's going to be a lot simpler that way. And so we need the area of the base. Well, how do you take the area of a triangle? If you don't remember, you can go back and look at your formula sheet. But the area of a triangle is base times height divided by 2. Okay, so we're going to take base times height of the triangle divided by 2. This is the height of the triangle, okay? So for this one, maybe it would be a little bit more clear if I use a capital H for the height of the figure and a little h for that height of the triangle. So let's say this is the little h of the triangle, 8 centimeters, and the big H is going to be the 3 centimeters. Okay, so we're going to multiply that by 3 afterwards. So we've got a base of 6, a triangle height of 8 divided by 2, and then we're going to multiply that by 3. So if you do the math on that, what you are going to determine is that you have 48 divided by 2, 24 times 3, you've got 72. Check the units, centimeters cubed, because it's a volume. All right, let's give this one a go. Why not? Another triangular prism, and we're going to be asked to find the volume. What's the volume? Volume equals area of the base times height. Okay, so we're keeping it basic, same formula every time. The base, we're going to say the triangle is the base, okay, because that's going to make things simpler. So the base is going to be what I'm filling in with this disgusting blue mess, okay, and that's going to be 5 times 10, okay. Base is 5, height is 10, divided by 2, of course. Area of base times height divided by 2. I can articulate this a little more clearly, write the proper formula in there. Just trying to show my work, as you should, as clearly as possible. Base times height divided by 2. Then we're going to multiply that by the height on the side, which is 2. So we've got 5 times 10 over 2, and then we're going to multiply it by capital H, the height 2. So it's just going to be 5 times 10 for 50 cubic centimeters. All right, we're on a roll, so let's go ahead and do a cylinder as well. So determine the volume of a cylinder and the cylinder below. So the cylinder presented in the picture there. Again, you can mainly structure this as the volume is equal to the area of base times height. But what's important in a cylinder is that the base, and let me just switch up the colors. The base here should be the circle. Okay, so it should be one of the circular faces. Okay, so one of the circular faces should be the base. So we're going to go, if we take the area of the base, so we're going to find the gray area here, and then we're going to multiply it by the height, which is, of course, this measure of 30 from here to there. Okay, so how do we find the area of a circle? Take a second and consult your local formula sheet, and you'll see it is pi r squared. Okay, don't confuse this with surface area. We don't have to multiply it by 2 because we really just need it once, okay, to give us that 2-dimensional area on the end, and then we're going to multiply it by the 3rd dimension of height. Okay, so it's really going to end up being pi r squared times height. Let me clean up my writing here. Times height. Okay, so pi, we're going to use 3.14. You can hit the pi button on your calculator. The radius is given to us as 12, so it's going to be 12 squared, and then we're going to multiply that by 30. So everything's multiplying here, but you do want to pay attention to order of operations, and it's a good habit to do the exponent first. Okay, so 3.14 times 144, which is 12 squared, times 30, all in, punch it in your calculator, beep, 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 13,571.6, why not, 1 decimal place, cubic centimeters. So that's the volume of this figure. Now, if you want to think practically about what this means, okay, 30 centimeters is about like 1 foot. So if you had a foot tall cylinder, roughly, that were 12 centimeters in radius, so that's actually about, that is 24 centimeters in diameter. So it's quite a large sort of bucket. We're saying that that would hold over 13 liters. 13,000 cubic centimeters would be 13 liters. So that should make sense. It's a fairly large bucket. All right, how about another cylinder? Determine the volume of this cylinder. So that's, of course, going to be area of the base times height. And of course, for the base, we are going to purposefully select the circle for that, of course, right? So you're going to say, okay, the circle on the top or the circle on the bottom, same thing. What's the area of that circle? So area of a circle, we know, oops, let me get the right color here. Geez, trying to work out my pens. The area of the circle is going to be pi r squared, okay? And then we're going to multiply that by the height, which is 8. So now we can put real numbers in there. Now, the 4 we're given here, up here, that's actually a diameter, isn't it? So the diameter is equal to 4 meters. We know that the radius is going to be the diameter divided by 2. So the radius is actually going to be 2 meters, okay? So the radius is 2. So we have 3.14, that's pi, times 2 squared, which is going to be 4, ultimately. And then we're going to multiply it by the height of 8. All right, so if you plug it all in, what do you get? 4 times... punch it into my calculator. I did it before, to be honest. 100.5 square meters would be the volume of this cylinder. And what would you call this cylinder with such a silly face on it? Why, of course, this would be referred to as the cylinder. We all had a hearty laugh. Now, for this one, let's practice working backwards. What if, in the question, instead of being given all the dimensions and everything, you're given the volume, and you said the volume is 2,450 cubic centimeters. What is the height? Well, you can actually plug everything you know into the volume formula, area of base times height, okay? I guess in this one I've made the height little h, but, there's no golden rule on that. Fine. Okay, so area of base times height. And, of course, we're going to define the base again as the circle, right, in this case. Right, so we want to work out the circle. We know that the area of a circle formula is pi r squared. Okay, so, oops, let me get back to the right color. It's going to be pi r squared times whatever the height is. And we have these values. So we know that the volume is 2450. Okay, so 2450 equals 3.14. We know the radius. We're given the radius. It's 10. So we're at 10 squared in there. And then we're going to multiply it by h. Now what we need to do is isolate h in the equation. Okay, so how do we do that? Well, if you remember back to when we worked out basic algebra expressions, whatever is being done to the variable that you want to isolate, which in this case is h, you want to do the opposite. So h is being multiplied by all these values, and let's just go ahead and process it. So like 100, 10 times 10 is 100. Okay, this part is 100. And then 3.14. So it's going to end up being 314 times h, okay, according to my use of 3.14. So because we're multiplying here, if we want to isolate the h, we divide. We do the opposite, and then we make sure we do the same operation to both sides, okay? So to isolate h is going to ultimately be equal to 2450 over 314. What happened to 314 on this side? Well, because we divided it, it canceled out, right? So now we just need to process what's 2450 divided by 314, and I got to get up my calculator. Oh, I didn't have it ready. Oh my god, oh my god. Okay, it's 7.8. So H is equal to 7.8. What are our units? It was centimeters. Okay, so the height is 7.8 centimeters. Seems to make sense. Okay, one more for good measure. It's a triangular prism, and we want to calculate the volume. So try this one on your own, pause the video, and take a crack at it. Okay, should have used the formula volume equals area of base times height. You should remember that for a triangular prism, you want the base to be the triangle. Okay, there it is. So, what's the area of a triangle formula? Well, of course, it's base times height of the triangle divided by 2. And then we're going to multiply it by the height of the whole figure. The base of the triangle is 6, and the height is 7. Okay. And the height of the whole thing is 11. So we're going to end up having 21 times 11. 21 times 11 is 231 cubic centimeters. Okay, so the volume of that figure, 231 cubic centimeters. Now, hopefully this helps you work through and understand how to find the volume of those basic three-dimensional figures. And you should do the practice worksheets on determining volume of other figures as well to achieve mastery of this. Good luck to you. I'm available for help.